Hey everyone! As you observed my spinning of a piece of string, what did you see? By spinning a piece of string, I've made a circle. If a moving point and a fixed point is maintained at a fixed distance and move one round, that is 360 degrees, the locus of movement becomes a circle. If x squared plus y squared equals to r squared, it also represents a circle. If we use the locus of movement in the example just now, this is a circle. The fixed point is the center. The moving point which turns around it will form a closed curve, which is the circumference. The fixed distance, that is the straight line between the center and the circumference, is the radius. For a straight line which passes through the center from one point of the circumference to another point on the circumference, this line segment is known as a diameter. For a straight line which touches the circle on one point, the straight line is known as a tangent. These are some basic concepts and terms of a circle which you are very familiar with. Let me introduce you to more concepts and terms of a circle. A straight line between 2 points of the circumference is known as the chord. The part of the circumference between 2 points on the circumference is known as the arc. If the length of the arc is half that of the circumference, it is known as a semicircle. If the length of the arc is shorter than the semicircle, it is known as minor arc. Minor arc AB can be expressed in writing like this. If the length of the arc is longer than a semicircle, it is known as major arc. Major arc AB can be expressed in writing like this, where x being any point on the major arc. The area enclosed between an arc and a chord is known as a segment. The region enclosed by arc AB and chord AB is a segment. The region enclosed by arc AXB and chord AB is another segment. The region bounded by an arc and 2 radii is known as a sector. The sector bounded by minor arc AB and radii OA-OB is known as a minor sector. The sector bounded by major arc AXB and radii OA-OB is known as a major sector. We have talked about the relevant concepts and terms of a circle. Now, let us continue to talk about some special circles. If the radii of 2 circles are of the same length, then these 2 circles are known as equal circles. If the circles share the same center, then they are known as concentric circles. When a polygon is placed inside a circle, that is, all vertices of the polygon are on the circumference, the circle is known as a circumscribed circle. If a circle is enclosed by a polygon, that is, each side of the polygon touches the circle, that is, each side of the polygon is a tangent of the circle, the circle is known as an inscribed circle. In this diagram, which concepts and terms of a circle can you name? Just now we have discussed some concepts and terms of circles. Next, let us discuss the property and theorem related to circles, beginning with those related to chords. In a circle, there is a chord. The perpendicular line from the center to the chord bisects the chord. The theorem is, the perpendicular from the center of a circle to a chord bisects the chord. The converse theorem of this theorem is, The line joining the center of a circle and the midpoint of a chord is perpendicular to the chord. Based on these two theorems, the corollary can be deducted that the perpendicular bisector of a chord passes through the center. If two chords in a circle are of equal length, then they are at equal distance to the center. The theorem is equal chords of a circle are equidistant from the center. The converse theorem of this theorem is chords equidistant from center are equal. We have discussed 5 theorems. Now there is an applied problem for us to exercise our minds and to find out the answer. Here is a circle, but we don't know where the center is. Now we have a pencil, a ruler, and a compass. Please try to find out where the center is. Now, let us discuss some angles in a circle. In these circles, there is an angle at the center and an angle at the circumference. There is an angle at the center and an angle at the circumference, subtended by the same arc. The theorem is, the angle at the center, subtended by an arc, is twice the angle at the circumference, subtended by the same arc. If the two radii link up to become a diameter, then the angle at the center is straight angle. Now, according to the theorem that the angle at the center subtended by an arc is twice the angle at the circumference subtended by the same arc, then the angle at the circumference, it's a right angle. If AB is a diameter, The theorem is the angle in a semicircle. The converse theorem of this theorem is if the angle at the circumference subtended by a chord is a right angle, then the chord is a diameter. The theorem is the converse of angle in semicircle. The following theorem is related only to angles at the circumference. In the same segment, all angles at the circumference are equal. The theorem is angles in the same segment. There is a circle here. Let us find out the angles in a circle and the relevant theorems. Moments ago, we have discussed a theorem regarding the chord, the arc, and the angles in a circle. Next, we're going to discuss the relationships among them as well as the relevant theorems. In a circle, equal angles at the center stand on equal arcs. The theorem is equal angles, equal arcs. The converse theorem of this theorem is equal arcs, equal angles. When there are equal angles at the center, they stand on equal chords. The theorem is equal angles, equal chords. The converse theorem of this theorem is equal chords, equal angles. So, the property and theorem relating to chord and arc are: in a circle, equal chords cut off equal arcs. The theorem is equal chords, equal arcs. Conversely, the chords of equal arcs are equal. The converse theorem is equal arcs, equal chords. In a circle, arcs are proportional to their corresponding angles at the center. The theorem is arcs proportional to angles at center. In addition to arcs proportional to angles at the center, the length of the arc is also proportional to the angles they subtended at the circumference. The theorem is arcs proportional to angles at circumference. After getting to know the concepts of circles, the relevant properties and theorems, we can apply them in calculations or to prove the relevant geometric problem regarding circles. One last sharing to make with all of you, and that is do more observations, exercise our minds frequently, and attempt more. Learning geometry is fun.